So for our project, we decided to build a bus tracker app for the U of I bus system. There are currently many bus trackers out there, but most of them, especially Illini Bus, the most popular one, don't really personalize the experience for the user. They just show you buses that are arriving nearby without like any consideration for where you're trying to go. So our bus tracker app is aiming to solve that problem. And to do this, we ask the user a few questions to get started. First, we just ask their name. Then we ask whether it's a weekday, Saturday, or Sunday because bus routes differ depending on the day. We also ask what bus route they're taking and where they're trying to get on and get off at so that we can give them arrival times for where they're getting on and arrival times for where they're getting off so they know how long their trip is going to take.
When you first open our app, this is the page that you're going to see. If you were to click the More Information button, it'll bring you to a page that lists off predetermined information. And for this to work, the button calls Info Page Start, which basically starts up the help class, which is where we actually decide what is displayed.
So we've already entered some data into the main page of our app just for brevity. And when the search for upcoming times button is clicked, the data is sent into the switch screens function where it is stored as an edit text variable and then passed through to the bus list class where we use it to actually contact the API and get different bus times.
Moving into the bus list class, one of the first challenges we faced was correctly handling user input. The CUMTD API has specific keys that they use to identify bus routes and stops, so to convert the user input into something the API can use, I created some 2D arrays to store the input key pairs. The expected user input is stored in the first dimension, and any API keys associated with that input are stored in the second dimension. For example, the 220 route appears right here and is followed by its associated daytime, evening, and late night API keys. To locate the correct keys using the system, we loop through the first dimension to look for any index where the input matches our expected input, and if one is found, all associated keys are stored for later use. And then if the user inputs any text that doesn't match any of our expected inputs, we simply send them back to the main page.
So after we've converted the user input to usable inputs for the API, we then call the start API function, where we pass through the start ID where the user's getting on the bus, the end ID where the user's getting off the bus, and the route ID of the bus the user's taking. And then we actually call the CUMTD website in our code using our API key and get the different arrival times for the bus that they want to take. And so this call results in an output that looks like this from the website. And then we have to format this by searching for the expected arrival times using this and the vehicle ID of the different buses that are arriving. And once we've gathered the times and the vehicle IDs, we have to convert the bus times to things on a 12-hour clock because the original times are set in a 24-hour clock. And we use the vehicle ID to match up the correct buses with their arrival times because some buses might have already arrived at one stop but not at another yet. So then we actually complete this process a second time and find the arrival times of the bus at the end stop for where the user's trying to arrive at. And we use the vehicle ID to actually compare the arriving buses at the start and end stops to make sure that we're displaying the times, that we're matching the times correctly between the buses at the start and the end stops. And then if the bus times that we found are null in the first index of the array, which means no bus times were found, then we recurse through the array using the evening and the late night route for that bus. And the reason we do this is because originally we always call the API call using the daytime bus, regardless of when the user is actually getting on the bus. So in order to make sure that we're getting the user all the possible buses for their time, we have to also check the evening and late night routes if the daytime route returns a null value. And then if we still get a null value for our return, then we change the null to be a blank space right here so that we don't display null on our output.
So currently our app is most usable by experienced MTD transit users that have a general sense of where stops are located and which routes pass through which stops. Moving forward, we aim to make our app far more usable to those that have little or even no experience with the system. And we do this by changing how the input is actually gathered. We plan to provide an interactive map for each bus route, allowing users to select where they wish to board and exit the bus by clicking on stops on the map. And we also aim to gather data from the system regarding time and date, which would eliminate the need for the user to input the day and eliminate the need for our recursive API calling.